Hi, my name's Emily, my partner's name's Maya, and here's our final project for ECE 353. So for this project, we had to use a TIVA C-Series launchpad connected to a bunch of these peripheral devices to make a short video game. So our game's called Polar Plunge. You play as a polar bear that's sledding down a hill, and you have to avoid obstacles as they come flying at you by clicking this right button to jump. There's 3 modes to the game. You can either sled down the hill slowly by holding the joystick in the left position. You can sled at a normal pace just by holding it in the center and not touching it. And then you can sled faster by pushing it to the right. So here's our game over screen. I just lost. To start the game again, I can touch the capacitive touch screen, and the I2C interface sends a signal to our code to start the game again. Here's our welcome page, also uses I2C. Oh, in the corner here we have a high score. We set up the EEPROM to hold the highest score on this device from our game. So you can see upon reset, it stays there at 253, that high score I got once. Same goes for if I unplug and replug the board back into my computer. So I'm going to go ahead and start the game by touching the screen again, and I'll kind of demo the 3 modes I was talking about. So first I'll start slowly. Here, as the joystick's in the left position, my bear jumps slower, and the enemies also render slower or come at me slower. If I keep the joystick in the middle position, you can see it speeds up. You can also see I'll go faster if I'm in the right hand position. Oh, too fast. So we use these red LEDs on the right here to indicate how many lives you have left. You start with 5, and then slowly as you get hit, they decrease like that. So the red LEDs we triggered via the I2C IO expander interface. We also use the I2C IO expander interface to control these push buttons. So whenever you click one, an interrupt's generated, and then we can read it in our code and do the following operation based on what push button it was. So obviously do nothing if it was these 3, jump in if it was this one. So our joystick uses the ADC interface. We have a timer that generates an ADC interrupt every so often so that we can read the value of the joystick and then update the speed accordingly once that ADC handler gets triggered. We also have this UART to USB interface here, which allows us to pause the game by pressing the spacebar on my computer over there. So I can demo that real quick. In PuTTY, it displays right now just that the game's running. Then once I pause, the game will pause on here, and PuTTY will display a paused message for us. Ouch. Okay. Yeah, and that's all of our game. I hope you enjoyed. It was really fun to make. We had a great time in the class, and it's really exciting to have this final project to show. So, thank you.